What's up people, and welcome to my tutorial in Pragmatic Data Science. So in the previous videos we went through the different similarity measurements that you could be using, and in this video we're going to take a look at the implementation of cosine similarity and Jaccard similarity. So I'm going to be working with the main6.py file here, and I've copy-pasted most of the data. Reading in the data is identical to the previous one, and the parsing and normalizing of the data is also exactly the same. I used the normalize from the sklearn pre-processing library. So the cosine similarity here, you get two vectors, and I use the dot product from NumPy, and in that case I get the numerator, and this is actually what we're implementing here. So we're going to do the dot product here in the numerator, and for the denominator here we're going to do the norm of x and y vectors, and the norm here is going to be the p norm, where p is equal to 2. So I'm going to do this one right here for both of the vectors, but with p is equal to 2. Alright, so let's take a look at the denominator here. I calculate the norms like this, fairly straightforward just from the example. And there I get the x and y norm, and then I get the denominator just by multiplying them, and then I take the division of that and return it, right? For the Jaccard similarity is also fairly straightforward. Let's take a look at the implementation of that. The Jaccard coefficient, so I do m11 over m01, m10, and m11. And that's how you get the Jaccard similarity. And that is what I do here. I iterate over all of the items or the indexes and the vectors. It's assumed that they have the same length here. And then you do that and return this division, right? So in terms of application, what I do, I read in the data, I normalize it, I get a row, an integer input from the user, what row we should be finding similar items to, and then I just take that row from the CSV file and check the most similar other day that had most similar type of weather to that day. And I do that for both Jaccard and cosine similarity. And I skip the ith row where I is equal to the row number because, of course, it's going to have a perfect similarity to itself. So this is why I do this, right? And then I check the Jaccard and cosine similarity, grab the best one, and print that out. And I suggest you clone the GitHub repository and check out the implementation so that you will easily follow along. So if I run this, it's going to take a little bit of time to read in the data and firing up, right? So now we want a row. Let's just select the first row. And yeah, I also forget to tell you that when I do this, when I do the cosine similarity, I skip the first column because that is the date column. And it doesn't really make sense to find similarity based on this date because, you know, date hasn't to do anything at all with the weather, right? And so I skip that. And for the Jaccard similarity, I skip the first columns because I use the 12th column to the end. So basically I use this sections here because these are Boolean values. That is going to be 1 and 0 after the normalization. All right, so that was that. And that means when I print out first, this is the row, this is the row 0, and these are the most similar with the cosine and the most similar with the Jaccard similarity. And remember, this first column is skipped, so you can ignore that. But this column right here, it had a very similar value to the cosine similarity, and you can see that these are a very good match, and it had a cosine similarity of 0.99. And you can also see that it makes sense because they are very similar in types of weather. This column was probably the most non-equal, I would say, or dissimilar. But the other ones here are almost identical or very, very close. So I would say that the cosine similarity in this case gives a very good match of a similar type of day that had a similar type of weather, right? And for the Jaccard similarity, it got a perfect score. And the reason why it got a perfect score is because these 12 columns here, they match up identically to the 12 columns that was used for the original data. And if you remember from the data set, also these columns are saying the same thing because these are aggregated from threshold values, I would assume, from the other one. Like if the millimeters per rain go over 0, the rain was raining column here, of course, will be set to yes. So they kind of modeled the same problem. And you can see that gave a perfect Jacquard score. And if we also take a look at the other columns here, you can see that they also have some similarity here. But if you check out the actual values here, you can see that it is not as accurate as the cosine similarity in this case. And that is kind of expected in a way, because you're losing resolution when you only use this binary 1 and 0 and yes or no thing, as opposed to using the actual floating point values from the different columns that have floating point values, right? And that is the trade-off that you get. It is an easier implementation, but sometimes the cosine similarity is probably better if you can implement it, because it uses floating point values instead. So you would lose that kind of resolution when you are using set theory instead, when you do the Jacquard implementation of it. But of course, sometimes you only have Boolean values, and in that case, the Jacquard is probably the way to go. And that was all for this video. I hope you guys liked the actual implementation of this, and feel free to go ahead and implement the Pearson correlation also, and which would also work in this particular data set. And if you have any questions or anything, leave in the comment section. Otherwise, don't forget to subscribe, and I will see you in the next video. Bye bye.